You've probably heard numerous players like myself saying don't do mixed belts, except for certain situations, most notably resource lines that head to your storage. But what if I were to say we're wrong, and that it might be the perfect solution to some of your larger factories? Well, let's get into it. Now, the main reason for not using sushi belts is by keeping one item on each belt, you keep a system simple and much easier to troubleshoot when you have issues. After all, if all your belts run a single item and then you find two items on a saturated belt, it's quite easy to know where the problem is. But there are use cases for mixed belts, and for players who love to optimize builds by reducing excess buildables, a sushi belt can be the perfect answer to certain situations. But before we get into that, we need to understand belting. A sushi or mixed belt is a term where two or more resources merge onto the same belt, whereas dedicated belts are belts which have a single item on them. The problem with sushi belts is that if not set up correctly, one factory input can become saturated, causing a backlog of resources, which in turn deadlocks the factory. But there is an easy solution to this, which we'll get to shortly. When it comes to these sushi belts, because you merge multiple resources onto them, it's beneficial to have the highest tier belt possible, ensuring high speed throughput of resources. Generally speaking, this means that I don't use them unless it's for syncing items, or I have at the very least tier 4 belts available. It's also incredibly important to have smart splitters unlocked for this, and these can be unlocked easily and early in the game by researching Criterium in the MAM, but I wouldn't recommend mixing belts prior to this unless it is specifically for just sending items to the awesome sync. When it comes to use cases for sushi belts, they're generally quite varied and useful. Firstly, they're fantastic for sorting items, which makes them the perfect belt system for dropping off resources at your storage to be distributed, whether that's clearing a full inventory of build parts or for depositing resources from exploring to be turned into the likes of biofuel, alien DNA, or power shards and the likes. Secondly, it's also great for low resource requiring later tier items. This is because sushi belts naturally have a reduced throughput of resources. For example, a dedicated Mark IV belt of plastic can have up to 480 plastic on it. However, if a sushi belt is also mixing with the plastic concrete, this then splits the throughput of that belt, which is 480 items per minute, between two resources. This is an issue for high resource operations, but when you look at the later tier items, they tend to require fewer and fewer resources. Just look at the late game space elevator parts, for example. This means that you can run them on a single belt and it won't really hinder production unless you're building lots of them. Thirdly, they can be used to create smart manifolds. These produce items when one production line isn't running, essentially creating an OR gate kind of logic system. So for example, you can create motors with a sushi belt containing rotors and stators. However, if we add AI limiters to the belt, which we're syncing for points, for example, you can then connect this to a priority power switch. We can then choose to turn it off and the resources will flow to the next section, allowing us to produce a different item, which in this case could be using the stators and the AI limiters to produce electromagnetic control rods while syncing the excess rotors. And what's great about this is there's no reason to say that you can't have a handful of different resources on this belt. So you could produce any number of items in small quantities through using this method. And this is great for giving you flexible production lines, allowing you to really choose what you need when you need it. And this also has the added bonus of being very compact. You could put 4 lines worth of resources on a single line, saving you a lot of space. But this does have its own issues though, and you won't be using it everywhere. Firstly, they don't work well if you're needing to run a lot of one particular resource along a line. For example, screws, wire, copper powder, all of these are generally big no-nos when it comes to running mixed belts. because these belts will be quickly saturated by the resources that you need lots of. This doesn't mean that you can't produce items that require large amounts of one item, just don't use that item on a sushi belt. Perhaps add a dedicated belt for those items whilst running a sushi belt for the others. In fact, in the demonstration at the end of this video, I'll make sure to include a recipe that needs a dedicated line so that you can see how it would run. Secondly, you wouldn't want to use these on buildables that require only one solid resource, for example, smelters, constructors, packagers, and refineries. With each of these only having one solid input to output, they tend to favor dedicated lines. This way you can create a dedicated factory line that runs at a constant max speed. Now there are exceptions to this rule, but generally speaking, it's not necessary. One might be, for example, resources that have been dropped off from exploring, or perhaps creating a smart manifold system with numerous small amounts of resources. Thirdly, when it comes to setting up these, you need to run them alongside awesome sinks, because if one item saturates a line, the whole belt will come to a standstill. By the way, if you are enjoying this video, I should mention to hit the thumbs up, and if you want to see more, don't forget to subscribe. Now that we've covered the use cases and the issues with them, it's actually time to set up a dedicated line as a reference for you. Now here we have 4 manufacturers, each producing the normal computer recipe requiring 10 circuit boards, 9 cable, 18 plastic, and 52 screws per computer. Do note this recipe includes the consumption of 520 screws per minute, which is far too much for a sushi line. So in this example, we will run a dedicated screw line alongside our sushi line. Before continuing though, make sure that the total throughput of all the items on this sushi belt manifold do not exceed the speed of the belt. For example, adding up all the resources we need per minute, then multiplying them by the amount of manufacturers we will run, we can see that we will need 370 resources on the sushi line per minute. This is within the max throughput of a Mark V and a Mark IV belt, so we can continue with the build. Now first we will set up the dedicated screw line, and with that set up we can now see how much space we have available for the sushi line. As this item has 4 inputs, we will place a smart splitter in front of each input that is not occupied by a dedicated line, which in this circumstance is all of the inputs but the screw input. Sure, if we had a programmable splitter, as I'm sure some of you may be mentioning, we could use a single input for all the resources, but this can actually cause the input to saturate and prevent the manufacturing line from running. Therefore, use smart splitters. Now, once you've placed a smart splitter in front of each of the inputs, we will go into the smart splitter menu and add a dedicated resource for entering the manufacturer for each of the smart splitters. Here, for me, the first one is set to circuit boards, the second cable, and the third plastic. The center line should be set to overflow, with the sushi belt flowing from one side of the manifold through the middle of all the smart splitters to the end of the line before sending the excess resources to an awesome sink to maintain the resource flow. You can then merge the outputs onto another sushi line or send them to another factory or storage. So there you are. This is how to set up an efficient sushi line. Why not let me know in the comments what you'd like me to cover next? But until next time, we're going to leave it there. Special thanks does go to all of our amazing supporters on Patreon, most notably our Solo Eclipse patron Firefless, our Lunas, the Calamity, Ben and Star, and our Blood Moon of the day, which today is the Viking Brit. Until next time, as always, ciao for now.